Okay, now we're going to continue our discussion on vectors. Today we'll look at vectors and dot products. Last time we talked about scalar multiplication and what? Addition of vectors. So the dot product is a way of kind of multiplying vectors. Okay? Let's look at the definition. What does it mean to take the dot product of two vectors? The dot product of the vector u in component form, u1, u2, and v in component form, v1, v2, is given by u dot v is u1 times v1 plus u2 times v2. So we multiply the corresponding components and we take their sum. Notice that taking the dot product does not result in a vector, but it results in what? A scalar, or just a real number, okay? That is the dot product. We have some properties of the dot product. The first property is u dot v is the same as v dot u. So it does not matter the order that you take the dot product with, okay? Number two, the zero vector, if we dot it with any vector, will give us the number 0 back. The zero vector dot any vector is the number 0. And number three, u dot, the sum of v and w, is the same as u dot v plus u dot w. So we have kind of a distributive property going on here. Number four, if we take the dot product of a vector with itself, then it's the same as taking the magnitude or the length of that vector and squaring it. And number five, if we have a constant c, and so we can take the dot product and multiply that by c, or it is equivalent to multiplying that first vector by c and then taking the dot product of v, or multiplying the second vector by c and taking that dot product with u. So we can take the dot product first and then multiply. We can multiply with the first vector, take the dot, or the second vector and then take the dot. So those are just some properties. Let's look at an example. Let's find u dot v if u is given to be 3i plus 4j and v is given to be 7i minus 2j. Now, this was defined based on component form, but we know that here the component form is what? 3, 4, and here this component form is 7, negative 2. So u dot v is what? 3 times 7 plus 4 times negative 2. So what is that? 21 minus 8, which is 13. Okay? So it's what? u1 times v1 plus u2 times v2. That's the dot product. Y'all still with me? Any questions so far? Still right. Okay. U dot v is what? We take the product of the u1 and v1 plus the product of the u2 and v2. So we have what? 3 times 7 plus 4 times negative 2. So that's 21 minus 8, which is 13. So get another example. Let's use the dot product to find the magnitude of this vector u, which has components 2 and negative 4. So it says use the dot product to find the magnitude. So we have this property here where u dot u is the magnitude of u squared. Which means what? The magnitude of u is what? The square root of u dot u. Right? We have this property here that u dot u is the length of u squared, so I can find the length of u by doing what? Taking the square root of both sides. So what is u dot u? Well, it's u1 times u1, right? Which is 2 squared, or 2 times 2, it is 2 squared, plus what? u2 times u2 is negative 4 times negative 4. So we have what? 4 plus 16, which is what? 20. So it's the square root of 20, which can be reduced to 2 square root of 5. So we can use this property to find a length by taking what? The square root of both sides. Okay? Okay, because we're doing u dot u, which is what? U dot u will be u1 times u1 plus u2 times u2, right? U dot v is u1 times v1, u2 times v2. Here u and v are the same. So it's really u1 squared plus u2 squared, basically. Any other questions? Okay, we can find the angle between two non-zero vectors. If theta is the angle between two non-zero vectors, u and v, then cosine theta will equal u dot v over the length of u times the length of v. So we can find that angle theta. An alternative form for this, we can find the dot product. An alternative form will be u dot v will be what? The norm of u times the norm of v cosine theta. So we have an alternative form for finding the dot product now based on that formula. Okay, an alternative form for the dot product. Let's look at an example. Let's find the angle theta between the vector u, which is 2i minus 3j, and v, which is I minus 2j. Let's find the angle theta between those two vectors. Well, cosine theta is what? U dot V. Okay? What is U dot V? 2 times 1 plus what? Negative 3 times negative 2. What's the length of U? Is U1 squared, which is 4, plus U2 squared, which is 9. The length of V, U1 squared, which is 1. Excuse me, V1 squared, which is 1. V2 squared, which is what? 4. We square negative 2, we'll get 4. So what do I have? 6 plus 2 is 8. Okay? Then I have what? 9 plus 4 is 13, right? 1 plus 4 is 5. What's 13 times 5? 65. Because that's what it means to find the length of a vector. The length of U is the square root of U1 squared plus U2 squared. That's by definition.
It's okay to leave the radical in the denominator?
No, we're not done. We're just asking a question.
Well, because when I was doing the homework the other night, some of the answers were put the radical in the denominator.
I would accept it, but here we want to find theta. So we have to get a decimal approximation for this 8 over 65, which is about 0.99227. And then I need to find theta by doing what? Inverse cosine. So theta will be about 7.13 degrees. So yes, at this level, it is okay to leave radicals down there, but we had to get decimal approximation because we had to find the angle theta. Okay? We had to find the angle theta. Questions? Let's look at another one. Same direction. But now, U is given as cosine pi over 4i plus sine pi over 4j. And V is given as cosine pi over 2i plus sine pi over 2j. Same directions. Let's find the angle between these two vectors. So what we need to do first of all is to rewrite these vectors, because I can find out cosine of pi over 4 is what? Square root of 2 over 2. And sine of pi over 4 is also square root of 2 over 2. So I can actually figure out what that is and get a new form for U. What is V? Well, cosine pi over 2 is 0, and sine pi over 2 is 1. So now I have new vectors U and V. Okay, I just simply evaluated cosine and sine at those particular angles. So now I can find cosine theta is what? U dot V, so square root of 2 over 2 times 0 is 0. Square root of 2 over 2 times 1 leaves what? Square root of 2 over 2, that's U dot V. Then I need what? The length of U, which I go through what? I take the square root of what? When I square these components. What happens when I square root of 2 over 2? I get what? 2 over what? 4. And when I square root of 2 over 2, I get 2 over 4 again. When I square 0, I get 0. When I square 1, I get 1. So this turns out to be the square root of 2 over 2. And what is this? 2 halves plus 2 halves is 4 halves, which is 1. Square root of 1 is 1. So this is cosine theta. Cosine theta is what? Square root of 2 over 2, which means theta is what? pi over 4. That is the angle that has cosine square root 2 over 2. Okay, this here, okay, take the dot product, u dot v, u1 times v1, that's 0. u2 times v2, square root 2 over 2 times this 1 is square root 2 over 2. I need to take the length of u, which means I square this, right? So when I square the square root of 2, I get 2 back. When I square 2, I get 4, so that's 2 over 4. If I square this again, I get what? 2 over 4. Take the square root of it. I square 0, I get 0. I square 1, I get 1. Okay? So 2 fourths plus 2 fourths is 4 fourths, which is 1. Square root of 1 is 1. So my whole denominator is 1, and I'm left with my numerator, which is square root of 2 over 2.
How'd you get just square root of 2 over 2 on the numerator?
How do we get this?
Yeah, just like one thing.
Because when we took the dot product, this comes from the dot. Remember, this is u dot v. That's the dot product.
I mean, I ain't really, I've just been trying to write and keep up.
But that's u dot v. That's the result of that dot product. u1 times v1 is 0. u2 times v2 is square root 2 over 2 times 1 was square root 2 over 2. So that's the dot product. Other questions? Let's look at something dealing with the alternative form for the dot product. Okay? Let's look at a problem where we may have to use this. Let's find u dot v, where theta is the angle between u and v, and the length of u is given to be 100, the length of v is given to be 250, and theta is given to be pi over 6. So they're giving us all our information. U dot v by this formula is what? The length of u, which is 100, the length of v, which is 250, times cosine pi over 6. So you can get cosine pi over 6 off your unit circle. 100 times 250 is 25,000. Cosine pi over 6 is square root of 3 over 2 from our unit circle. So 2 goes into 25,000, 12,500 times the square root of 3. So here, all of our information was pretty much what? Given. And they just wanted us to use the alternative form for their dot product. Okay?
On the last problem, when you got the vector u equals root 2 over 2, I plus root 2 over 2, j vector, how do you get that?
What are you talking about?
Like, right was the problem.
Uh-huh.
You got u vector equals root 2 over 2 plus how do you get that?
By cosine pi over 4 square root 2 over 2. By just evaluating.
Oh.
Just evaluating those functions. And cosine pi over 2 is 0. Alright, do you remember back in probably 100 or 112 somewhere where they said to find out if these lines are parallel, perpendicular, or neither? We're going to do something similar with vectors. But when we talk about perpendicular, in physics they talk about orthogonal. It means the same thing. Okay? But they're saying, are these vectors orthogonal, parallel, or neither? So let's define what orthogonal means as it relates to vectors. U and V are orthogonal if U dot V equals 0. And what that means again is that these vectors form 90-degree angles, just like perpendicular, but they're orthogonal if their dot product is 0. Okay? When we talked about two lines being parallel in dealing with lines, one was a constant multiple of the other, right? So as far as parallel goes, they are parallel if U is some constant times V. Okay? So if the vector U is some constant times V, then they're parallel. But if their dot products are 0 or is 0, then they are orthogonal. And if neither one of those situations happen, then they're neither. So let's look at some examples, and let's determine whether these vectors are orthogonal, parallel, or neither. And the first vectors, we'll look at U being the vector 3, 15, and V being the vector -1, 5. Now, first of all, we want to see, can I multiply one of these vectors by something and get to the other one? If I multiply this vector by 3, I have -3, +15. And it's not exactly U, is it? So one is not a constant multiple of the other. If this had been positive, then it would have been. Then they would have been parallel. If you can multiply one vector by a number and get the other vector back, they're parallel. But it's not parallel because I can multiply by 3 here, but I have -3, +15. So it's not parallel. Okay? So now I need to check and see what U dot V is. So 3 times -1 is -3, and 15 times 5. This gives me 72. So I don't get a dot product of 0, which means this thing is what? Neither parallel nor orthogonal. Okay?
How did you find out was parallel?
If I can multiply one of these vectors by a number and get to the other one. So it's not parallel because U is not some constant times V. Almost, but not quite.
What's the K mean?
A constant. Any constant. Let's look at another example. Suppose U is a vector with components cosine theta, sine theta. And V is a vector with components sine theta minus cosine theta. Now, I cannot multiply any one of these by a constant and get to the other. No way I can multiply sine by some constant and get the cosine. Okay? But what is U dot V? Well, I have cosine theta times sine theta minus sine theta cosine theta. And this is what? 0. So the dot product here is 0, which means these are orthogonal. Okay? The dot product is 0, which means they are orthogonal.
So orthogonal means that they're perpendicular?
Yes, that's how we relate it in physics. It means that what it means is that these vectors form a 90-degree angle. But they just call it a different word in physics, and they say orthogonal.
Well, how can you can do the not parallel and neither for the first example? How can it be both?
I mean, I'm saying it's not parallel. I mean, it's not parallel, and
It's not perpendicular.
And right here, because of this is not 0, it means it's not orthogonal. Which means the answer is neither. It's neither parallel nor orthogonal.
Well, if it's not parallel, then
it doesn't have to be parallel or orthogonal, because that one's neither one, so that's why we say neither. Because the question was to see if it's parallel, perpendicular, or neither. And it's neither one of them, so it's neither. Now, let's look at what's called vector components. Vector components. Let U and V be non-zero vectors such that U is W1 plus W2, where W1 and W2 are orthogonal, and W1 is parallel to V. Okay? So what that means is that out here somewhere, we have some vector here, U. This is the angle, theta. Okay? It says that, and we have some vector right here, V. Okay? It says that W1 plus W2 is U. So I can call this my W2 vector because W2 and W1 are also orthogonal, but W1 is also parallel to U. So if I drop my vertical here, I can say if I go out here, all of this is my W1 vector. Now don't get all in a roar because you don't necessarily understand this picture, because there's more that we're going to say about this. So let U and V be non-zero vectors such that U is the sum of W1 and W2. And W1, W2 are orthogonal, which means they form a 90-degree angle. Okay? And W1 is parallel to V, which means what? Pretty much the scalar multiple. Okay? The vector or the vectors W1 and W2 are called vector components of U. The vector W1 is the projection of U onto V, and is denoted by W1 is projection of U onto V, and its formula is U dot V divided by the length of V squared, all times the vector V. This is how we find W1. The vector W2 is U minus W1. Okay? And W2 is referred to as the vector component of U orthogonal to V. So essentially, in the problem that we're about to do, they're going to want you to find W1 and W2 based on a U and a V that they're giving you. Okay? So, an example may read, find the projection of U onto V and the vector component of U orthogonal to V, where they give us that U is -3, -2, and V is -4, -1. So in essence, when they say the projection of U onto V, they're saying find W1. And when they say the vector component of U orthogonal to V, they're saying find W2. Okay? And essentially you have to follow the formula. Well, W1, we need what? U dot V, which is what? 12 plus 2, right? -3 times -4 is 12. -2 times -1 is 2. And we need what? The length of V squared, which is what? The length of V is the square root of V1 squared plus V2 squared. So the length of V squared is just V1 squared plus what? V2 squared, right? That's the formula for the length. If we square both sides, we don't need that square root anymore. So it's what? 16 plus what? 1. Is that correct? -4 squared is 16. 1 squared is 1. And all of this is times the vector what? V, which is -4, -1. So what do I have essentially? I have 14 over 17 times this vector, -4, -1, which is what? If I multiply 14 times -4, I get -56 over 17 and -14 over 17. That's my W1. Okay? W1 is U dot V, the length of V squared. All that's a constant, and I multiply by this vector what? V. Any questions about W1? What's W2? U minus W1. So U, -3, -2, minus my W1. -3 minus 56 over 17 is a positive 5 over 17. And -2 minus 14 over 17 is a -20 over 17. So if given U and V, I can find W1 and I can find W2. But you need to know what W1 and W2 represent. W1 represents the projection of U onto V, and W2 will represent the vector component of U orthogonal to V. Any questions about what we've done today? All right. If there are no more questions, then this will complete our talk about vectors and dot products for today.